Welcome to the NMENA video tutorials on CSP technologies, Block 6, Unit 5. My name is Nicole Janot and I shall introduce you to ultrasonic flow measurements. Today we have chosen the Contas test facility to demonstrate how the sensors will be mounted and the readings will be taken. We're actually measuring the velocity of the flow and will then deduce the flow rate from those measurements. Therefore, it is very important that the flow profile must be undisturbed. This is assured by a long undependent piping length that is sufficiently far away from any upstream disturbances. The details of the selection of a measurement point will be explained in the theoretical unit. Furthermore, we have chosen a horizontal piece of piping located at the inlet of the collector. This way, we have the lowest temperatures that we can possibly obtain in the system, and this is important for the ultrasonic sensors. In preparation of the measurement and sensor mounting, we need to dismantle the insulation of the piping. So there we are with just the metal piping left. In order to proceed, we will need to clean the piping from dust and rust and any particles. For ultrasonic flow measurements, it is particularly important that the pipe surface is smooth and free of any dust, paint, rust or other obstructions to the signals, so that the acoustic coupling of the signals to the pipe is optimum. In this particular case, we know that the piping is relatively cold. Otherwise, during actual operation with circulating heat transfer fluid, the piping can be hot, so you need to make sure to protect yourselves from any burns. In order to set up the flow sensors correctly, we need to know the geometry of the piping. So we will measure the outer diameter of the pipe and its wall thickness. For measuring the outer diameter, we use a sliding caliper. And we measure several times around the circumference of the pipe in order to get its average value. The wall thickness of the pipe is determined by ultrasonic measurements. They use the travel time difference to determine the thickness from the time needed for the signal to pass through the wall material and its longitudinal speed of sound. We apply coupling gel to the tip of the sensor in order to assure that the acoustic signal passes well from the sensor to the pipe. And then we probe the pipe with the tip of the sensor. Again, we take several measurements around the circumference of the pipe and then calculate its average value. For the quality of those measurements, it is essential that the longitudinal speed of sound is entered correctly into the calculation. For the measurement of the flow rate, we use a pair of ultrasonic sensors. We then enter the geometry that we just measured into the evaluation device, which then calculates the spacing of the sensors. Once we know the adequate spacing of the sensors, we can adjust them on the ruler. Again, ultrasonic coupling gel is used to optimize the signal strength. Then the sensors are clamped to the pipe . And firmly adjusted. If all values are correct, the measurement can start. Let me just summarize 2 essentials for good quality ultrasonic clamp-on flow measurements. First of all fluid and material properties need to be entered correctly in order to obtain the correct sensor spacing. And secondly, the sensors have to be mounted very precisely in order to have the best signal strength and least uncertainty of the measurement. We have just seen how to measure the volumetric flow rate using an ultrasonic flow meter. If we wanted to determine the mass flow rate instead of the volumetric flow rate, we would need an additional temperature signal and the temperature dependence of the density to calculate that mass flow rate. Some instruments offer the option of including such a signal and thus can directly convert volumetric flow rate into mass flow rate. On the other hand, the use of such an additional temperature signal is very beneficial for the uncertainty, as temperature dependencies of fluid parameters can be corrected for directly during the measurement process.